Alright, this video is going to be on long division. Sorry I'm posting it so late. I got distracted watching too much Star Trek. So, long division. The reason that we use this is we can't always use synthetic division. We can only use synthetic division when we're dividing polynomials by a linear binomial with a leading coefficient of 1. So if I had something like x squared plus 6x plus 3 divided by x plus 2. This is linear because the exponent is 1. It's a binomial because I have two terms here, and it has a leading coefficient of 1. So that one I can use synthetic division on. But a lot of times we get stuff that isn't in this format, and so we can't use synthetic division. So we use long division. So if I have something like this, this is still linear, and it is still a binomial, but it doesn't have a leading coefficient of 1. So I can't use that synthetic division. Because the leading coefficient of 3 is 3, I'm not going to be able to use synthetic division. So I'm going to use long division. So just so that we remember how to use long division, I want you to remember when you divided numbers. We're going to follow the same process. So I look at the first number and I say, how many times can I divide it by 2? I can't. I multiply 0 times 2. I put it right here and I subtract. 1 minus 0 is 1, and I bring the next number down. Then I divide this by 2. How many times does 2 go into 14? It's 7. I multiply those together. It's 14. I subtract, and the next number comes down. How many times does 2 go into 7? 3. 3 times 2 is 6. I subtract. Next number comes down. How many times does 2 go into 16? It's 8. I multiply those. I subtract. The next number comes down. How many times does 2 go into 3? 1. I multiply those together. Subtract. And the next number comes down. How many times does 2 go into 12? 6. And this is my answer. So we're going to do something very similar. All right, so I'm going to use this same problem right here. I'm going to set it up the same way that I have the long division right here. So what goes on the outside is what I'm dividing by. What I'm dividing into goes on the inside. So remember, I look at the first term and I see how many times does this go into it. So I say, how many times, what's left over when I divide 3x cubed by 3x? Well, the 3's cancel out, so that's 1. One of these x's cancel out, so I'm left with x squared. 1x squared. Then I have to multiply this by both of these terms. So x squared times 3x is 3x cubed. These should always be the same. X squared times 1 is x squared. I put this in parentheses because I'm going to subtract both of those things. 3x cubed minus 3x cubed cancels out. Negative 17x squared minus x squared is negative 18x squared. Everything else comes down. I once again divide the first term by the first term. So what's left over when I divide negative 18 by 3? Negative 6. What's left over when I divide x squared by x? X. And I multiply this times both of these. Negative 6x times 3x is negative 18x squared. Negative 6x times 1 is negative 6x. Put this in parentheses because I'm going to subtract. These cancel out. 19x minus negative 6x is 25x. Oops. The next number comes down. I look at what's left over when I divide this by this. And that's not going to go in evenly. Why is that? Did it do something wrong? I feel like I did. I made a mistake. Okay, so just give me a break on this one. I'm going to pretend that it's 27, okay? I know it's not, but I'm going to pretend it is because I don't want any remainders today. So this divided by this gives me 9. I multiply it by both of these. And I subtract. Everything cancels out. No remainder, which means what I get when I divide this by this is x squared minus 6x plus 9. Alright? I'm going to do a couple more. Hopefully I don't have any typos on my other examples. So I have x to the 6 plus 8, x to the 5 plus 10, x to the 4 plus 4, x to the 3 plus 9, x squared plus 2x divided by x squared plus 2x. I divide the first term by the first term. What's left when I divide x to the 6 by x squared? It's x to the 4. I multiply this times both of these. X to the 4 times x to the 2 is x to the 6. X to the 4 times 2x is 2x to the 5. And I subtract. These cancel out. 8x to the 5 minus 2x to the 5 is 6x to the 5. Everything else comes down. I divide the first term by the first term. What's left when I divide 6x to the 5 by x squared? I'm going to be left with 6x to the 3. And then I multiply this times both of these guys. So it's going to give me 6x to the 5 plus 12x to the 4. And I subtract these. These cancel out. 10x to the 4 minus 12x to the 4 is negative 2x to the 4. Everything else comes down. Divide my first term by my first term. I'm left with negative 2x squared. Multiply this by both of these. Gives me negative 2x to the 4 minus 4x to the 3. I subtract this. These cancel out. 4x to the 3 minus negative is plus. 4 plus 4 is 8. X to the 3. Everything else comes down. Divide my first term by my first term. 8x cubed divided by x squared is 8x. This gets multiplied by both of them. Gives me 8x cubed plus 16x squared. And I'm going to subtract that. These cancel out. That gives me negative 7x squared. The next number comes down. Divide the first term by the first term. Gives me negative 7. And I'm going to multiply this times both of these. And I did make another typo. Come on, Latimer. So I'm going to get negative 7x squared minus 14x. Subtract that. We're going to pretend that these are the same number just because I don't want any remainders today. So we're going to pretend that all cancels out, which means this is our answer. So we'll do some examples in class. I want you to bring into class with you these two problems, these two solutions, okay? And I want you to show all the work so that you can follow it along as you're going, all right?